Today we're going to be looking at the surface area of triangular prisms. As a reminder, for prisms, we have two parallel and congruent bases. The base shape is the shape that the three-dimensional shape is, so triangles for a triangular prism. And then the lateral sides are rectangles. So a triangular prism, a triangle has three sides, so it has three rectangular lateral sides. When we look at this and think of it as a net for surface area, we have our two triangle bases and then we have three lateral faces. And those sides connect to the triangle. So the side lengths of these should be the side lengths of the triangle. It might be easier to visualize with something like this where we have different lengths. So this example was equilateral triangles. This has scalene, three different sides. So this side length right here matches with that side. This side obviously is the same, and then this side matches with this. So you have your two triangle bases, three rectangles, and the three lengths of those rectangles match with the three lengths of the triangle. So let's look at example one. I'm gonna do the first one by drawing a net, and then we're gonna do the others without. So what I'm going to do is I'm just gonna draw a net with three rectangular lateral faces and the triangle base. Now, I'm going to match up the side lengths of this triangle. So we have our smallest side length of the triangle here is 3. I'm gonna match that up with the base length of the triangle there. So that's a side length of 3. My second side length is this middle side of 4. That's gonna be my middle length here of 4. And then my last one, the longest side here of 5, is gonna be my last side length here of 5. Now, when we think about the sides of the triangle, these two right here fold into each other. So this height right here would be 3. These two fold into each other. So that side length right here would be 5. But really for the triangle, the ones that matter are the two that are connected at the 90-degree angle, just like on the actual shape. And then the last side length that's given to us is this length of 9. That's connecting the front triangle to the back triangle. So that's this height here that's connecting all three of these together. So that height was 9. So now we can go and find the area of each of these. We've got our first rectangle, which is 3 times 9. That gives me an area of 27. Our next rectangle is a 4 times 9, or 36. Our last rectangle is 5 times 9, or 45. Now for our triangle, we do base times height divided by 2. So base of 4 times height of 3 is 12. 12 divided by 2 is 6. And those triangles are the same, so they're both 6. And then we'd be able to add these up. So we have 27 plus 36 plus 45 plus 6 plus 6 to get that our total surface area for this prism is 120 centimeters, and we're talking about area, so it's squared because it's the flat surface. So knowing that, let's try these next ones without using the net. So what I'm just gonna identify here in my shape is my base. So base doesn't always mean bottom, it's that shape that determines what type of prism it is. So we have this triangle right here, which has 3 side lengths. We have 4.9, we have 2.6. Even though it doesn't say this length right here, it's the same as this length, so it's 5.5. So for my triangle, I have these 3 sides, 2.6, 4.9, 5.5. And we are gonna multiply each of those side lengths by that length that connects the front triangle to the back triangle. So by 1.1. Just like for over here, that length connecting was the height for all of those. So now I'm just going to multiply those. 2.6 times 1.1 is 2.86. 4.9 times 1.1 is 5.39. 5.5 times 1.1 is 6.05. Now the last part is our base. We're looking at this triangle, we're looking for the 90-degree symbol. That 90-degree symbol is connecting the 2.6 side and the 4.9 side. So for our triangle, we're doing our base of 2.6 times our height of 4.9, dividing it by 2 to figure out what one of the triangles is, but we need 2 of those. You might notice that technically you could look at it as, well, if I'm dividing by 2 and then multiplying by 2, those cancel each other out. And you're really just doing 2.6 times 4.9. Or go through the motions if you're not confident you're going to remember that. So if I did 2.6 times 4.9 and divided that by 2, I get 6.37. But we're multiplying that by 2 because there's 2 triangles, and you get 12.74. So now we're adding those all together to get that the total surface area is 27.04 centimeters squared. All right, number 3. The orientation of this prism is a little bit different. We still know that it's a prism because it doesn't come to one point. We know it's a triangular prism because of that triangle base. So these two, it was like front and back triangles. This one, it's top and bottom. So I'm going to highlight this triangle. Now, we need the 3 side lengths of the triangle. This one is already listed as 15. This one doesn't have a number, so we look at the same one on the bottom is 20. And this right here doesn't have a number, so we look at the same one on the bottom, which is 13.2. So our 3 side lengths, 13.2, 15, and 20. We are multiplying each of those by the height that connects the 2 triangles. This case, it's from top to bottom. So it's this height right here of 5. So we're going to multiply those each by 5. 13.2 times 5 is 66. 15 times 5 is 75. 20 times 5 is 100. Now for our base triangle, we look for that 90-degree symbol. That's connecting the 13.2 and the 15. So we're going to do our base of 13.2 times our height of 15 divided by 2 for one of the triangles, but we have 2 of them, so we're doubling that. When we multiply that out, we get 198. And then we're going to add those all together to get that our total surface area is 439 meters squared. Number 4, I'm going to identify my triangle on the top or the bottom. I'm just going to do the top one right here. Okay, when we're figuring out our 3 rectangular lateral sides, we need the 3 side lengths of the triangle. This triangle doesn't have any of them listed. So this side right here, I'm going to look at the same one on the bottom, which is 6. This side right here, the same one on the bottom, is 12. And this one right here, the same one on the bottom, is 9. So our 3 measures, 6, 9, and 12. We are multiplying that by the height that connects the 2 triangles together, the top to the bottom, which is this height of 8. So I'm going to multiply that. 6 times 8 is 48. 9 times 8 is 72. 12 times 8 is 96. Now, for our area, all the other 3, they had 2 of the side lengths be your base and height because they were connected at a 90-degree angle. They were right triangular prisms. This one is not. You'll notice we have our 90-degree symbol right here. The sides that connect is this side of 6 and then this perpendicular height of 10. So for the triangle, we're doing our base of 6 times our height of 10 divided by 2 for one of the triangles, but doubled for 2 of them, which is going to give us 60. And we're going to add these all together to get that our total surface area is 276 meters squared. All right, last one. Finding my triangle, highlighting it. We need the 3 side lengths of the triangle here. We have this side length is 16, this side length is 10, this side length is 10. So we've got 16, so I'm gonna do over here, 16, 10, and 10. This triangle was in the front, so we're looking at the measure that connects the front to the back, which is that length of 30. So for each of these, we are multiplying by 30. So I'm going to calculate 16 times 30 is 480. 30 times 10 is 300. 30 times 10 is 300. Now, we need to find our triangle base. The 90-degree symbol is connecting the side length of 16 and this perpendicular height, which is identified as 6. So we're doing 16 times 6 divided by 2 for one of the triangles, and then doubled because there's 2 of those triangles, and we get 96. And now we're going to add them all together to get a total surface area of 1,176 meters squared.